Hello, everyone. I'm very happy to share with you today. And the content shared today is divided into two parts. And the first part, PyFlink, is shared by myself. And the second part regarding the Flink on Zeppelin is shared by my colleague, Jeff. Yeah. And I will divide the content of PyFlink into three sections. And first, I'd like to introduce the benefit of PyFlink to Python and Flink, and why Flink prefer Python as a multi-language support. Uh, and second, I'd like to report the current situation of PyFlink. And finally, I would like to introduce the future plan of PyFlink. And before today's sharing, I'd like to make a brief introduction to myself first. And I'm a staff engineer at Alibaba, and I have involved in ASF since 2016. Now I'm a PMC member of Apache Flink and a committer for Flink, Beam, and LTDB. And I was very lucky to be elected as an ASF member at this year. Yeah. Okay. Let's start the first section of talk. Why PyFlink? Um. So, what's the benefits of PyFlink to Python and Flink? Yeah, for the Python, increase the user base. That is, Flink is not only for Java, Scala, and SQL user, but also for Python users. And for Python, PyFlink make some Python libraries have distribute computing power. The big difference is from the standalone mode to the cluster mode. Yeah. And okay, why Python applies to Flink for multi-language instead of Go or R, and why user choose PyFlink over PySpark or PyHive? And first, we talk about why Flink. Yeah, Flink is a pure stream architecture, and I think the millisecond delay made almost real-time computing. Yeah, and Flink is validated by many big data companies in the production environment, such as Flink create a peak of more than 2.5 billion date recorder per second in Alibaba. So Flink is your first choice for the big computing. Yeah. And regarding why Flink choose Python for multi-language, because the ecologic of Python is pretty good, and Python is the most popular language besides Java and C. So I think Python is the best choice for Flink to support multi-language. Yeah. We have a brief understanding why PyFlink, and let's talk about the status of PyFlink. Yeah. First of all, I would like to introduce the goals of PyFlink. First, Python. One is the goal. One of the goal is expose Flink functionality to Python users, and another um, distribute the functionality of Python through the Flink, which means that PyFlink will make some Python libraries to have distributed computing power. Yeah. Okay, we have defined the goal of PyFlink, but how do we achieve those goals? Let's see. Mm, For the goals of PyFlink, we need to have a Python engine on Flink, just like the existing Java engine? The answer is no, because attempt has been made in Flink 1.8 and which show it's not a good way. Yeah. And there is a principle of design that is achieve a goal at minimal cost. Therefore, the best way is to reuse the existing Java engine by only providing the a set of Python APIs. Yeah. Then what Python APIs should we provide in Flink? Yeah. So as we know, in the Flink, there are two very important APIs. One is a high-level API, is table API and circle, and another is stateful API, datastream API. So we need those two APIs to for Python users. And okay, how do we realize this kind of API in PyFlink? Yeah. Um, we should to know that the core problem to support Python API is the communication, yeah, between between the VMs, and how can we solve it? And we should take a look at the API architecture for in the PyFlink. If we solve the VM problems and we almost achieve the goal of expose the existing functionality of PyFlink to Python users. Yeah, that's what Flink 1.9 does. So let's take a look at the architecture of Python API in the Flink 1.9. First, we using the Py4j to solve the communication problems, and then we start a gateway and in Python VM and start a gateway server in Java VM and receive accept the requirements from the Python API. And we should define all the objects and class aligned with Java, such as table environment, and so on. We should mapping one v one mapping the API between the Python and Java APIs. Yeah. So of course, in 1.9 we also defined various of job deployments, such as the Python, the py shell, and CLI, and we also support Circle client in the future. Yeah, so in this design, we can see that uh, when uh, uh, when user uh, writing the Python API will call the Java APIs. Yeah, of course. In this architecture, we will have many benefits. Yeah, let's see. First, the architecture is very simple, which means we just align the API, mapping the API between the Java and the Python. And secondly, we can have a high performance, yeah, which means Python have the same performance with Java. And as we know, the Java made a peak real-time computing processing speed more than 2.5 billion recorders per second. Yeah. So that's all the benefits from this architecture. Okay. And we quickly introduced the PyFlink, how to expose the Flink functionality to Python users with Py4j. And then we talk about PyFlink, how to integrate the Python functionality into Flink. Yeah. Um, we know that Python has many successful libraries, and those libraries solve problems in different fields. Yeah, but for Flink, the common feature of those libraries is that they can be used as user-defined functions of Flink. So our core problem is how to execute those functions in Flink. And Flink 1.10 solves these problems with the Beam portability framework. And let's talk about the user-defined function architecture in Flink 1.10. And in this architecture, we should consider not only the communication between the Java VM and the Python VM, but also consider the different requirements in the compile part and the runtime part. In the picture, we show the behavior of Java VM in wallet and the Python VM in blue. First, we take a look at the compile part. The design of local is per API mapping, and it still use Py4j to solve the communication problems. That is every Python API executed as shown in the picture will call the Java APIs. But for support the user-defined function, we should add more APIs such as register functions. And we also need to add the dependence management APIs such as a series of add methods such as the add Python file. Yeah, and after finish the Python job development, the Java API will build the job graph and submit the job to the cluster by CLI and CLI or command line and many ways. So let's take a look at the behavior of the Python and Java operators at runtime. First, the on the Java side, job master assign the task to the task manager, and task manager will execute the tasks. Task involve the execution of Java and Python operators. In Python user-defined function operator, we will design various gRPC services for the communication between Java and Python VM. Yeah, such as date service and state service. So also have login service and magic service. And those gRPC services build on the function API of Beam, and then the user-defined function will execute in the Python worker. After that, the result, we also using the gRPC service to return the result to the Java operators. And well, I would like to call this part of design is Flink on Beam. Of course, the worker of Python is not only a precise model, but also the Docker model and even an internal service cluster. Yeah. Well, this is a architecture of user-defined function in PyFlink, and let's see what benefits from we can got from this architecture. First, the Beam is a mature multi-language support framework. We can easily extend the support of other language in PyFlink. And second, is easy to maintain. That is, the same framework is maintained and optimized by Beam and Flink, which are very active communities. Yeah. Okay. So after understanding the existing API and user-defined function architecture of PyFlink, let's take a look at what APIs are exposed by PyFlink. PyFlink is fully aligned with the Java Table API and support all kinds of relation operations. And I want to remind that remind that there are some very convenient APIs support in the PyFlink table API, such as which is very powerful than Circle, just like the column APIs, add columns, drop columns, and so on. And in currently we also have well support for the Windows. And besides this, and we also support many ways to define a user-defined function. And currently, the PyFlink is suitable for the following use case, such as event-driven applications and data pipeline applications, and so on. Yeah. Okay. After that, we should know how to using the PyFlink. And before we writing the PyFlink job, we should install the PyFlink. Yeah. Currently, we can install the PyFlink using the pipe install command line, which is pipe install Apache Flink. And currently, we also support PyFlink share for users, which is very convenient. Let's have a look at it. Okay, here we go. And first, we should check the Python version. Currently, we support 3.5, 3.6, and 3.7. And then we should install the PyFlink using py-install command. And after that, we can using the PyFlink shell directly in the command line and launch a PyFlink shell. And then we can write anything you want about the PyFlink job. Here I just copy a ETL job here and just show how to work of how does the PyFlink shell work. Okay, at last we run the execute method to submit the job to the mini cluster and waiting the result, and then read the result file to print the result. Yeah. Okay. Maybe need okay. It's here it is. Yeah, we got 2 hi hello and 3 hi hello. Yeah, that it is. Yeah, and welcome to PyFlink. Okay, and a more complex example will shown by the next part in the Zeppelin and okay, let's have a look at the feature of PyFlink. First, we should solve the communication problem for the Java VM and the Python VM. Then we should expose the Java table API to the Python users, which is done in the 1.9. And we should prepare to integrate the Python ecosystem to the Flink. So we should add the integrate with the Beam and do some prepare for the user-defined functions, and also add dependency management for the user-defined function. After that, we should add more libraries into the PyFlink, such as the pandas and pandas. We will support the series and data frame data structure in the PyFlink. And after that, we also add the support of reduced user-defined function in Circle DDL, and to solve the machine learning use case, we add the ML pipeline APIs, and for the rent production for the production, we also need to add a more metrics management for the user-defined function. So, however, those features are just the tip of the iceberg of PyFlink, and in the future we need to carry out performance optimization and also need some graph computing APIs, pandas native APIs, and so on. And all of those is the roadmap of PyFlink. And you can see we will also add some very native APIs such as Python pandas APIs into the PyFlink. Yeah. And this is all the roadmap of PyFlink, and let's looking forward it happen. Okay. Before release of Flink 1.11, I'd like to share some new features of PyFlink. First, the pandas UDF will be supported in Flink 1.11, and which means the user-defined function of pandas can be directly using in the PyFlink. You just add a UDF type in the definition of user-defined function. Okay, and we also add ML pipeline API support, which means you can solve some machine learning problems by PyFlink. And thirdly, performance optimization of user-defined function is expected to increase by 30 times, which is very important for save your money. Yeah. And last, we also add the syntax of registering Python user-defined function use circle in circle DDL, which means you can using the Python defined function in circle program. Okay, that's all. Let's welcome Jeff to talk about Flink and Zeppelin. And thank you, and welcome Jeff. Okay, thank you.
Okay, thank you, Jincheng, for the detailed demonstration of PyFlink. So next, I would like to talk about another exciting topic, Flink on Zeppelin. So first, I would like to give a brief introduction of myself. My name is Jeff Zhang. Currently, I work in Alibaba. Prior to that, I worked in Autodesk, eBay, Pivotal, and Hortonworks. So looking back my past experience, there's two key things. One is data, another is Apache. So in each company, I always do data-related work, including data processing, data analysis, or build the big data infrastructure. And I started to contribute to Apache pretty early, around 11 years ago. So and now I'm Apache member and 3 Apache project PMC. So now let's get back to today's topic. So what is Apache Zeppelin? Zeppelin is a web-based notebook that enables data-driven interactive data analysis with and collaborative documents with SQL, Scala, Python, and more. So here is a screenshot of what Zeppelin looks like. Here you will notice that you can write code in Zeppelin and you can run that code. Besides that, you can visualize the result intuitively. So next, I would like to talk about the architecture of Flink on Zeppelin. On the left side is the Zeppelin server, which is a web server that will serve requests from the front end. And the Zeppelin server can create Flink interpret, which is in a separate JVM process. And in the Flink interpreter, there's one Scala shell. The Scala shell is to run the Flink Scala code, and the Python shell to run the PyFlink code, and the SQL runner to run the Flink SQL. And each Flink interpreter can connect with one Flink cluster. So next, I would like to talk about a list of the features. So the first feature is the multiple language support. The most important thing is that the Scala, Python, and SQL, they run in the same same JVM. So that means they share the same environment. They share the same execution environment. They share the same table environment. So that means you can create a Scala UDF and use it in Python PyFlink table API, and vice versa. You can create a Python UDF and use it in Scala table API. And of course, you can use these both of these UDF in SQL. And the next feature is the different execution engine model. So that means you can run the Flink mini cluster in Zeppelin, and also the standalone cluster, and also the Yang session cluster. The dependency management in Zeppelin is a little different from that in Maven, but it is as easy as you can do in Maven. The next feature is the SQL result visualization. So that means you can visualize your data intuitively, because I think this is a pretty important feature for user, because without the visualization, you would not know whether you write the correct Flink job, right? The next feature is the Hive integration. So you can connect with Hive pretty easily just via view configuration. And the next feature is about interactive job control. So it is pretty easy to submit a Flink job and cancel that and resume that. I will do the demo to demonstrate how that works. And the next feature is a multiple thread job submission. So in Flink, actually, you cannot submit a job in multiple threads, but in Zeppelin, you can do that. The last feature is about machine learning support. So you can use the Alink, which is a machine learning library based on the Flink. So before I do the demo, I would like to talk about one important thing which I have learned. So the thing is that, in my opinion, there's 3 essential steps or 3 essential elements to build a Flink job. So step 1, you need to define the source and sink. And the best tool to define the source and sink is SQLDDL. So it is pretty easier to do that in SQLDDL compared with the Flink's Java or Scala API. And step 2, you need to build the DAG. So you can use the table API or SQL to build the DAG. Table API and SQL is almost equivalent, but in some very special case, you'd better to use the table API, because table API provide a little more functions than SQL. The step 3 is the business logic. So build the DAG is not enough. Sometimes you have to write complex business logic. So the best tool to implement the business logic is UDF. So that you can write UDF in Scala or in Python. So now it's demo time. Okay, now I will do the demo for you. So basically here I will do 2 demos. The first demo is about the real-time data analysis based on CDN access data. So here is the source data. So my source data is in the Kafka cluster. The topic is CDN events. So this data is JSON format, and I have the UUID, client IP, request time, response size, and URL, and then of course the event time step. So this is just a simulation of log of the CDN access. So let's get back to the Zeppelin. So as I mentioned, yeah, actually before I write any Flink code, I need to specify the dependency, because here I have the source data in the Kafka, and I will write the data into the MySQL database. So here I need the Flink Kafka connector and the Flink JDBC connector. So here I need to specify the property flink.execution.packages. And Zeppelin will download these packages for me automatically. and put them on the class path of the Flink interpreter. So let me run this. Yeah, it will be pretty fast. Now I will write the Flink code. So as I mentioned earlier, that step 1, I will define the source and the sink. So here I will first define the source table, which represents the data in the Kafka topic. So let me create that. And then I will create the sink table. The sink table represents the MySQL database. So here I need to specify the JDBC URL, the table name, username, and password. So after that, I would like to create a UDF. So here I will create a Python UDF. The UDF is the purpose of this UDF is pretty straightforward. It's just to convert the IP address to the province, and I will reduce that function. So let me run that. Yeah. And the logic is pretty simple. It will just call a REST API to ask to convert the IP address to the province. Okay. Now the next step is that I would like to verify whether this UDF is correct. So here I will just use the SQL statement to verify this UDF. And this SQL statement will start a Flink job. You'll notice that here we have the Flink job link, and that means the job is started. Yeah, and it will just take a few seconds. Let's just wait for a few seconds. It should be pretty fast. Okay, now we have the result. I'm sorry that the result is Chinese, but I think you can get what I mean. So the next step is that I would like to create a Flink job to do data analysis. So here I will use the PyFlink table API, and the logic here is very simple. So I will read the data from the source table and use the select to select necessary fields. Here I will use the UDF, and then I will do the group by, and then I will do the aggregation, such as the access count, the total download, and the download speed. Then I will insert that into the MySQL sync table. Then I will trick that job. Now let me start that. So it will just run this Python code, and it will trick the Flink job. You will notice that the Flink job link here. Okay, yeah, we can check that. It will bring us to the Flink web URL. Okay. Now, actually, you can do it in the PyFlink table API, but you can also do it the same thing in Scala table API, or do it by using the SQL directory. And the last thing I would like to talk about is that usually when you start the Flink job, you would like to check whether you write the correct Flink job, right? So here we can just query the table, query the sync table. So the sync table is in the MySQL database. So we can just query the MySQL database. Because Zeppelin is a tool that integrates with most of the popular data source and execution engines. So here we can just query the MySQL database directly in Zeppelin. Now let me run that. Oh, sorry, I just killed that process manually, so I need to restart it again. Let me, yeah. Okay, now we see the result here, right? So this is just the first demo about how to show you how to do real-time data analysis using the using different tools such as the SQL, the UDF, the table API. You can use them together in just one platform, Zeppelin. Okay, then I will do the second demo. The second demo is about the job control. So here I will just show you how to do how to submit Flink job and how to cancel that job and how to resume that job. Especially I will show you how to resume the job from the same save point. So here I need to register a new data source. So here the data source is just a simulation of web access logs. So I just assume that there's three kinds of pages: home page, search page, and the product page. Now let me run that. Yeah, and I will register that data source as a Flink table. The table name is log, and there are several fields: time, URL, and load time. Now I will just use the Flink SQL to query that table. For example, here I will try to calculate the PV for each page. So let me run that. Okay, as long as you see the Flink job links, that means the job is started, and you can see that the PV value is refreshed a little by little, right? It's increasing a little by little. And here is the cancel button, so we can cancel the Flink job by clicking that button. Let me cancel that. Okay, the job is cancelled. You can see the log here. Job was cancelled. So now I would like to resume that job and just pay attention to the PV value. Okay, the job is restarted, and you can see the PV value is still very low, and it is because the job is started from the very beginning stage. And let me cancel that again. So actually, this is not usually what you expect, because usually user would like to resume that job from the save point, right? So in the next example, I will show you how to resume a job from a save point. So here the SQL is the same as before, but I will provide some extra parameters: the parison, the max parison, and the save point. So now let me change the parison to be as 1, and let's restart that job. Okay, the job is started, and the P value is increasing a little by little. Let's click that button, and you can see the Flink job, and you will notice that the parison is 1 because this is what we specify here, right? And now let's cancel that job. So now I would like to resume that job from the same point, and also I will change the parison. Let's change it to be 2. So and I will resume that. Just pay attention to the PV value. Okay, you can notice that the PV value is not started from the very low number. It is because the job is restarted from the same point. And yeah, let's check the Flink job. Okay, you will notice that the parison is 2 because we have already updated the parison to be true, right? Okay, let me cancel that. So you can do it in the you can resume the job from in Flink SQL, but besides that, you can also do the same thing in the Scala table API, and also you can do the same thing in the Python table API. So basically, this is the second demo that I show you how to resume, how to control, how to do job control, submit job, cancel job, and resume job. Okay. Okay. So actually, there's many more features that I don't have time to demonstrate to you in this short talk. So here I just provide more material for you to learn. So first you can visit the Zeppelin website, And you can here I provide a list of Flink on Zeppelin tutorials. And last, you can follow me on Twitter. I will write articles from time to time. Yeah, I think this is pretty much about our talk. And thank you, everyone. Thank you for your time.